Hey, it's Alex from Blue Lightning Software once again today. Still worn out. I just wanted to come back to this from the previous video, looking at this was jobs versus Unity. Nothing means just Unity main thread, no special tricks, just the thing. These are cubes. Cubes creates a field of however many cubes we have here and repeat number on the right hand here. How many cubes, it just spreads them out randomly, cubes. Then nothing moves it by the amount of iterations here. Now this is interesting because each one of these moves it 0.1 of a foot. If you watch this, you can't see the moving because it's moving 1,000th of a meter per iteration. There you can see that's 1 meter per iteration, it's still 0.1,000th per iteration, but with 1,000 it's 1 meter per press set of iterations. Now, and the jobs do it much quicker. The jobs are just way quicker, but I was unfair in the test so far, which I thought about it on the way back from what I was up to today, and I got this wrong. I was definitely doing these transforms too many times. It makes sense, except the iteration should be within this loop, so it should have this. This is how the jobs are doing it. Okay, so totally to be fair, why didn't I like that? What went wrong? What just happened? You can't access transforms. Where was it? It was that. Everything was fine. I lost that. So the iterations needs to be, alright, let's do it like this. It's done. We forgot the second brace. We've got one brace too many. Totally lost. So the repeat is the different cube. Okay. So it should be this, and then it's only accessing, it's doing the same thing, but it's only accessing this position once. What it was doing was accessing the position, moving it 1,000th and repositioning it, whereas it should be doing all the movement, so all 1,000 times 1,000, so it gets the transform once, does all of the iterations of movement, and then puts the position back. And that's exactly what the job is doing. Yeah, it's got the position. Can make that more clear, couldn't we? It's got the position as float 3 vector. And here it's now doing exactly the same. That loops all the iterations, pretty same language. Okay, so now we should do the timing, and it won't be so extreme at all. It was massively different previously. I was like, wow, these are the best things ever. I imagine it's still much better, but let's see how different it is. So we're doing 1,000 so we can see it. Create the cubes, 1,000 cubes, 1,000 iteration repeat numbers. The iterations are how many times we move it, 1,000th. Oh wow, yeah, that's way quicker now, isn't it? Yeah, that was massively exaggerating the effect. So alright, let's try 10,000 cubes. Bit of sun flicker there. 120 is quite linear to the number of cubes, but it's still like jobs is just so much quicker. You can see it's moving them all. Every cube is going around and adding together these vectors and then moving it. It's just like so much quicker. These will fly off the screen a bit, but you see that should be 12 seconds ish. Jobs are still like, wow, that's so amazing. It is massively. The vector math within a job burst compiled is just amazingly quicker. It's incredible. The more of these, actually, this gives you a feel for less cubes, but more iterations. It's the same kind of thing. It's that number times it's mostly this work of vector math. There's a bit of overhead. Yeah, there is a bit of overhead in the transform stuff that's now removed. But, even with like 100 cubes, just a scattering of cubes, 115, alright, let's try it 1,000,000 times. And this is 1,000,000 additions. Yeah, it's all linear to that. It's not even the transform boxing. Not boxing, is it? It's, the get and set of the transform position. The job's just so much quicker. With 1,000,000 iterations, they've flown off the screen. That literally flies them off the screen. Yeah, you can still see the tail of them on even 100. So it's like moving the boxes 100 meters. They're meter wide boxes, if you can visualize it. So that's the time difference, and it's huge. It's huge time difference. Try 1,000 cubes. I just don't see how the jobs can be so quick by relatively. Million times jobs. Let's see it. 68 milliseconds. That's going to take like 10 seconds. It's still that different. Is it going to be 10,000, 11,000 milliseconds? Yeah, totally linear. That mathematical operation is the same time per time it does it. Just simple vector addition. That is the difference between a job and without the jobs. Just regular unity. It's incredible. It's a massive difference, and that's got that has to take from its output. Shows how quick the access is of these native arrays as well. I'll try and do this, okay, but this could just all go wrong. Let's try it. So we've got execute. How is it different now? Because it's going to go into this. Because what we're doing now is transform access position. Well, oh, that's interesting. So we don't need vector A. This should, right, what this is an iJob parallel 4 transform, okay, and this is an iJob parallel 4. So it's the 4s in the for loop. And this is job parallel 4 transform, okay. I'm just trying to replicate the same thing, but using transform this thing. So that's confused now. I set this up differently. I had a read only and complex iteration. Add vector, add vector. What's wrong with add vector? Position. Operator plus equals on float and v3. I didn't mind it here though, because float 3 position was that. It's the same. What's different between those? How did that become a vector 3? Because we set it from a vector 3. I'm not sure what it's trying to say though. Oh, I do now, so I'm stupid. I'm really honestly too tired to do this. Let's just get out. Let's get this going. Let's just make it work. Hold on. Whoops. Blindness set in. So it's all float 3s. You can just set a position, even though that position is a vector 3, it'll go straight into a float 3. Alright, so this is exactly the same as the other one now, I think. Except it doesn't actually even need vector A, because it has everything. It's got the before transform, and we're just taking the before and after position of the transform. Alright, so let's rig this up. What it is, this comes in as an array. Yeah, you got the index for the other one, and it just assumes that this array lines up, and it loops for each is this array when you execute it. So we try to demonstrate that. I've not done it yet, so I'm just kind of going to fumble it in. Let's see where spawn cubes job method. Here we go. Vector A no longer needs to be set. Job equals new Complexio job transform is coming in. Okay, let's just replace that line with this. That goes with that. That's kind of how I'm going to remember it. Okay, so what goes in there? You got to pass stuff in. Now you go to new it. Does it not pass stuff in? Nope. Okay, job add vector equals the same, complex iteration the same, output the same, job output the same, job schedule int job handle. There is no boxing. All right, hold on. So what's it saying? I'm going to have to refer to the guide. This is great. The one with the black background works for me. I can read this fine, better than the API. I think this is the manual, right? No, this is the script reference. What's going on? That is the manual. That's the manual, right? No. I'm just confused. It's the one with the black background, I call it. Just to be sure. I think it's the manual. Job schedule with the array goes in on the job schedule. Has he got no index there? Oh my god. Oh, probably the size of that input array sets actually the repeat number. Yeah, does that make sense? They will probably repeat, you know, it's not actually called a repeat number. What in this one is the length, you know, if it was still a normal parallel 4. Right, this just to get that is an array length and in a loop batch count. Okay. So what we have now, in fact, we'll comment this in case we ever go back to it. What we have now is purely passing in one of these, a transform access array. Where does it create? These are native arrays, okay. It's disposed of somewhere. See, it has to be disposed. It's not clear. Possibly is inside here. Transform access array implemented. Doesn't really say, but it counts as a native array for it needs to be disposed. So we need that here. So I can read it. What goes on with these? I think these are constructed from transform arrays, so we're in a good place. We've got one ready. Equals new transform access array. Let's see the overloads for that. Capacity. Yeah, transforms, just passing the transforms. So this transforms. We could have called this cube transforms, but don't worry about it. I'm going to get funny. So potentially this is it. We then just pass in transforms. No, we pass in the access array. Yeah, the transform access array. Created with the array of transforms that contains all the cube transforms that we created earlier. In spawn cubes, we loaded that up there. So it then goes to job finish. We no longer have vector A to dispose of. I'm changing too many things. This should be done. We don't need that. So I'd love to flip between the two, but I've forgotten the times already. It was, do we have a time? It was something like 69 for a lot of, yeah, so I'm not too clear the time. We could go back and look at it in the videos. Job finished. Job finished, job method. Where is the call to job finish, by the way? Jobs finished is called from jobs test. We're back here at jobs test. Okay. So job handles complete. Vector array was never actually created, but access array was. Yep. Just to prevent the memory leaks. Let's go. Let's do this. So hopefully this is the new method. I should really have a boolean that switches all that stuff, and we can see it happening. We won't even make cubes now because I'm press play. Temp job allocate. I just don't care. $1,000. Okay, so that's noticeable. The jobs don't even like it at all. Job not set to a reference. Oh, what was the? Oh, because I'm still trying to load it up. All of this goes together. Whoops. Yarg. This is the other method. Doesn't need that anymore. Let's reload. Knocking on the head after this, I think. Tired. So look, tests. Okay, let's get this to 1000. Oh god, did I really honestly press that? No. Cubes. Yeah, I did. No, it's not started. See, I'm going crazy. I don't. You got to press cubes first in this example. Cubes. We got our cubes. Nothing takes 12 milliseconds. Jobs take. I can't actually tell you if that's different. Let's do it 10,000 cubes. Index was outside. Again. Vector 3 transforms n. Oh, because I changed the cubes number. I didn't recreate cubes. I might get away with it. It might be broken inside. I might do better to restart it. I can see what I want now is to switch between the two types of jobs and see if this transform, because what it saved us doing it this way. It's taking the transform array of the cubes and putting them into a transform access array that is then iterating everything based on that. Okay, using an iJob parallel 4 transform rather than the iJob parallel 4, which goes through vector A into the output. Now vector A, does that even need an output? That's really interesting. Do you know? Wow. I'll do that now because it will make it make sense. It doesn't even need an output because it's got the access array. Are they read-only? I don't think so. Either way, I didn't put it into the memory afterwards. They're not read-only, are they? No, that wouldn't make sense. No, it's totally access to those transforms. So rather than an output that we would then reassign, we take transform access position and set it to the position we've just amended. There is no output. We don't need an output array. I just wondering how quickly I can rewind this to the other one. That no longer is needed. The thing above it is no longer needed. Just made them really obvious. Just using the access array, and then when it's done, so it does all the job method. Job's finished. Is job's finished? Waiting for it to finish, and then this is no longer needed. Job output was never actually needed to be disposed because it was a temp job. So I think we just did that there. That's done. All right. We should be able to see if it works. So that's the gist of it. It's now directly accessing the transforms within the native environment using a native access array. So transform access array. They're actually called native transform. No, transform access array, but they are technically like a native array of transforms. Let's see that. Here it comes. That is set to 1,000. Let's do 10,000 cubes. Or let's do 1,000 just to make sure it works. Set our cubes. Straight to jobs. That strikes me as really quick. I'm going to create the cubes again. Press jobs 20 milliseconds. I can't remember the times. 10,000, 10,000. 115 for 10,000, 10,000. Obviously it kills. Nothing is going to loop on for a while. That's like 10 faster. I'm not sure that's faster. Right, what somebody said, okay, some weird stuff online. This executes on the main thread unless you do something really weird. Based on it, right, there's just some spooky, not an old wives' tale, just some information I've seen on forums that this, if these cubes are all within one parent, if you look to the left on the scene thing, all these cubes we create are within this parent transforms, yeah. I read some bizarre stuff that if you use this transform access array, people are saying it's not threading, which is consistent with that timing actually, that it's not threading because these, and it's based on these all the cubes all being within the same game object. That's not, you know, within the same parent game object transform. It looks like that's maybe true actually. I was seeing stuff on that forums for 2018, so I was wondering if it had changed. I can try and prove the timing. I think I can prove the timing. That's about it. I could look in. I'm not very good at the profile of threads to find all the threads and say, oh look, wow, it's created all those threads. It's definitely threading. I'm not completely prepared to do that right now. I'll try and do a Boolean switch so that we can switch methods quicker within this object. So, I mean, it is so lightning fast without even without doing this, and it appears faster with just like loading the native vector arrays into float 3s. Arrays of native arrays of float 3 seem to be quicker anyway. Way quick enough. This looks advantageous in that you're using burst. I'm suggesting that burst worked, and burst worked in so much as I loaded a float 3 here of the position, and then we did add vector as a float 3, and we did burst mathematics, so all the math was done in burst, and that gave us the 10 times, what looks like a 10 times. The other 10 times is from the multi-threading, which is why job system not doing it this way in parallel, but in parallel 4 is 100 times quicker. This is like 10 times. The other 10 is from the threads. I'll just try and prove the timing difference. I'm pretty sure if I went back and deleted everything, it would be. I don't use vars ever. Oh my god, it won't even let me know that. What? Oh, I screwed it. I don't know how to switch it var. Oh god. Seen that? It's nutty, isn't it? Alright. Okay, then this remains the same. Oh, wow, so it's totally shafted because it won't. We've got to set it as 1 and then we can change it. Man. Technically that's slowing down. Oh no, it won't let me change it. Oh, I hate vars, mate. So we've got to have 2. Oh yeah, it's not too bad actually. Don't worry, it's not too bad. Got to duplicate all this stuff. Pain in the butt. So, because what I would do normally would be this. What's the core of them? Well, let me do that. Because yeah. iJob. What's the common? Because they're interfaces, aren't they? So it's not inherited. Dang. Right, so rubbish now. Here we go. And then we'll have to do this twice, just to make sense of it. Alright. Oh, but job doesn't exist. Oh yeah, because no, this is different in each of these. No, this makes sense. I just did it separately. This bit does. Ugh, Fumble Fingers is here. Okay, otherwise it was just schedule. Where did I keep that? I kept that good. Then we're all good. We got job handle either way. We don't need that down there anymore. I think that's good. That's the job handle was all we needed to get out of these. Okay, we're going to do another one of these. These are if nots. What was that? Honestly, I'm so tired. I apologise for this fumbling. There's something in jobs finished. Very similar. Not the access array, factor array. Else, lies are not else access array. Dispose, bang, that will work. It's tidy. Care. I think we're good. One version of method used the create an output. Where was that output array stuff going on here? Remember this needed doing. Where do I need that? Probably here. I think we're done. Yeah, that looks fine. Okay, so we should be able to switch between them a bit quickly. Cocked it all up. It's gone wrong. Let's check it out. Queues got queues, nothing works. Jobs works. That's with jobs. User access array. Does jobs still work? Jobs was quicker. Wow, there we go. Oh no, it's too fine to call it. Hold on, I'm not expecting it to be quicker. We'll have more queues. We've got the 10,000 cubes. That's without the array. Yeah, user access array is slower. That's what I expected. So let's see it. That's quite a bit slower. Yeah, can you see that without using that access array is much quicker? That suggests that the myth, not myth, the knowledge of the access array does not thread properly. All of this is going on the main thread, so it doesn't multi-thread when you use that access array in the way that we've used it, which a lot of people attribute to these having the same parent. I could prove that, okay, but it might give me a headache right now, because I would just take the cubes for that example and try them just in a scene so they don't have a parent, which is totally possible. Alright, just for the purpose of a demonstration, we might do that. Why did I even create them with a parent? I think I created with them a parent. A, it looks neater. B, it was easier to find them as children if I ever needed to do it like that. But I've got the transforms here. Spawn cube instantiate without the parent transform. Object transform, and it returns that transform and it loads it there, yeah? Okay, so I don't need a parent. I think that's going to work, and we can test this theory. Notice they were about 10 times for the thread. Let's just see if that worked. Trying to say something about the temp job somehow. This might be leaky. We should check that. See, they're all here. They're not in a parent transform anymore. We've created those cubes. We press jobs. Okay. See, it's a bit busy now. We can't see what's going on. Let's create 10,000 cubes. Seven and 12 without the access array. Let's make them move a bit more. 5 and 15. Okay, with the access array. Yeah, no, that brings you back in the park. Did you notice that? Still, well, at this kind of level, yeah, so we've proved this theory. In multi-threads, if they do not have the same parent, yeah, every transform in the access array, this bizarre, weirdest argument I saw on the threads. If those objects transforms have the same parent, it bunches them onto the main thread. I don't know how that transposes to, what if I had like 10 different parents, which I'm not about to test, but would that mean that they don't go to the main thread? You just get 10 threads. I don't know, honestly. I'm not sure how that exactly works, that one, but there is. It's not destroying them either. It forgot how to destroy them. So hold on. Alright, so this should be. To find them by renderers. Alright, so we'll stop doing that. I was finding them from the parent transform purely for this destroy. So if transforms dot not equal to null, and then equals transforms length. X bang transforms l.game object. Okay. Destroy. So yeah, that was just an overhang of the last way of doing it. So that's interesting. If they don't have the same parent, let's create 10,000 of them. do 10,000 iterations. Cubes, press play. Cubes. That is destroying the old ones, yeah. It's not massively layering up cubes there. There's a new fresh 10k cubes every time. Yep. Double check that. 19 and 9 and 19, so we're going to need more iterations to make it really visible because they're so quick. 5 and 51. With the access array, 14 and 90. It's slower anyway. This access array is slower anyway, I would say. 12 and 86. I'm only resetting these cubes so I can see them fly off the screen or not. It seems pretty consistent, doesn't it? It's like 12 and 87, 90. It's without that array. Yeah, without the access array is quicker anyway. Just doing the way we've done it here. That is quicker anyway. Not accessing an access array is quicker. So I think that's positively proved. In this, the way it's rigged up here, even if you insist it's multi-threaded, the access array is about half speed. No, not quite half. It's this different. It's nearly half as slow. Yeah, that's what we could garner from that. Let's have a look. Yeah, just a different way of doing it. The recap. Where is it? Yeah, just the it's all in that vector. The output and then the load up. If not using the access array, we load. They're doing this extra work of loading the vector native float array, native array of float threes, loading that up, and when you're finished, unloading back into and putting it back into the transform positions is quicker than using the native access array in an iParallel for transform. You could argue that's simpler. All right, it's not a massively exaggerated time. It's like that half fast. So as long as you've got these outside the parent, these don't share the same parent. Otherwise, they won't multi-thread. It will lock your main thread, and it will just be bad. And 10 times slower. These would just be half as slow. Can I even deal with 100,000 cubes? It's taking its time. I'll try this kind of thing. Right, that's 100,000 cubes. What's going on? I'm not going to recreate them. They're going to fly off the screen and we just see that they were working. 117 and 871 for using the access array. Yeah, Mars quicker. It's just quicker. 51, that's fairly consistent. Yeah, it's about double, isn't it? Yeah, the access array is half as fast anyway, even if you've got these outside the parent. So that's a take home from that. Mars quick. If I press nothing now, it'd be over. I'd probably have to use Task Manager. It would just explode. It would take forever. So yeah, way quicker doing that kind of thing. And that was an interesting look at the access array that you may, even though it's a bit slow, might want to use it for kind of, what's the word? Code ergonomics or whatever you call it. All right then.